So let's go into main here. Let's make sure this is all saved. I'm going to go into the main method of the console application. We'll play around with some of these classes and the interfaces and stuff. So I'll open up program here. And, program starts off with just, my regular comments. You can add yourself as an author if you like and change the date to today's date. I'm using system, also using system diagnostics, specifically for the debug class, which we'll look at where I'm actually using it. But I want to give myself little debug messages as I'm testing things out. Now, in your downloaded version, you probably have inside the namespace a class called inherit test. This is something we'll use for a little bit later on when we create our own classes, specifically the train class. We'll just minimize that for now. Now in class program, you have your main method, and in a try block with lots of different comments, a catch block to catch an exception and show its message, and just a little console, press any key to end at the end. There's a method down there. We'll look at that later on. But at any rate, what we're going to do is we're just going to, walk through. We're going to uncomment some of these things and just test things out. At the moment, what's going on in the try block is we're creating a test object a car, I should say, called test object that just accepts the default arguments for the car constructor. And then we skip over all this junk. We write the test object to string. So we're going to see the properties of the car as it's initialized. Okay, so I'll go ahead and run that. And this is what we see. So the passenger capacity, the default was 4. There's no passengers in the car yet because we haven't loaded any up. It's a gasoline car. This is the fuel consumption and so on. Okay, so that's a basic car. Let's try to do the same thing with just a generic vehicle. So I'm going to comment this out and I'm going to uncomment the line above it, which is essentially doing the same thing but using a vehicle instead. Now I can go and click run, but you'll notice that there was some red squigglies before we got started. So I'm going to say no. The error that I'm getting here is the fact that I can't create an instance of a vehicle. So this is just confirming that the vehicle class is in fact abstract. I can't create any objects from it. So that's something to keep in mind. I can create cars. I can use the default. This example here on this line, I'm creating test object. I'm calling the constructor and I'm specifying a couple of the parameters in order. Okay, the first parameter was the number of passengers and the second parameter was the energy type. Okay, so I'm specifying those as different than the defaults and then accepting the rest of them as defaults. If I go and run that, I can see the difference in the output here, 5 passengers and it's a diesel car. Another alternative that you could do that's a little different than in C++ is that you can actually specify the parameters in whatever order you want by specifying them by name. So let's say I wanted to create a car object and I was okay with the number of passengers and the energy type. Specifically what I wanted to initialize this particular car to was an 80-liter tank with an energy consumption rate of 0.1. So those are different than the defaults, but they're later on in the parameters. So I would have to, if I was doing this in C++, I'd have to specify all the parameters before them. In C#, I could say, no, this is the parameter that I want to set to 80. This is the parameter that I want to set to 0.1. Everything else will be the default. So when I go ahead and run that, okay, you can see the defaults for in gasoline and passenger load, but the consumption and the gasoline capacity have actually been changed. So that's a cool thing you can do in C#. All right. I should also test out the truck as well. So I'll uncomment out the truck version. Okay, and it all should work pretty much the same way. Obviously, when I run the program, I'm no longer getting passenger and capacity and load, but rather cargo capacity and load. And the actual default values are all different, but the concept is still there, even though it's a different type of object. Now, if I was testing this out comprehensively, of course I would do, all kinds of different combinations, cars and trucks and accepting parameters, not accepting parameters, different parameters. You know, this is giving me sort of the general, most of the stuff works, but I would take a few more, do a few more of these to actually test out to make sure. Any rate, let's move on. I'd like to take the test object, right now it's a truck, and we're going to modify some of the properties and utilize some of the actual methods. So we'll uncomment out these lines here. These are all properties that are, sorry, uncomment them out. These are all properties that are related to the vehicle. Okay, so since a truck is a vehicle, it has all these properties. Even if I were to go back and look at the truck definition, I don't see them because they're defined as part of the vehicle class. So I'm changing the energy property of the truck to electricity. So we got an electric truck. Okay, the consumption rate, 0.24 kilowatt hours per kilometer, and the energy capacity is 125 kilowatt hours. So we'll make those modifications. I'll run the program, and we can see that, again, because truck inherits vehicle, we have no trouble modifying the vehicle-based properties. Oops, flopping around here. Okay, now, of course, a truck is not a car, so if I try to modify one of the car properties, it's going to give me an error here saying, hey, passenger load just doesn't exist. Okay, so a car is a sibling to a truck. I don't actually have one. But of course I can modify the truck properties as well. Okay, so I'll modify the cargo load to 200 here. I'll go ahead and run that. And now you can see I managed to actually load some cargo on here, about 44.2% of the capacity of this particular truck. What if I tried to do something higher? So let's say 600 kilograms rather than 200 kilograms. And I go to try to run that again. And this is just a quick test of some of my error handling. So built into that property was throwing this exception. So this is jumped down to the catch block and telling me I can't set the cargo load to 600 kilogram because it can't exceed the capacity of 453 based on this particular truck. I see the parameter value and the actual value. So that makes debugging rather easy. We'll change it back to 200. Okay, so it's working again. We can play around with the method, so I can recharge the truck or refuel the truck. Both of these do functionally the same thing. Because I'm doing one after the other, instead of 40, is this electric? Yeah, it's electric at this point. So instead of adding 40 kilowatt hours to the battery, it's going to be adding 80 kilowatt hours to the battery. So I'll go ahead and run that and we'll see what happens. Okay, so we were able to charge the battery up that much because there was no electricity remaining. So now it's 80 kilowatt hours, which is 64% of the capacity. All right, and of course you can play around with those numbers as well. If I were to make this, 40,000, clearly that's going to be way too much, so it throws the exception. But of course I don't actually want to do that. And let's test what happens if I move the truck. I'm going to try to move the truck 300 kilometers, so we'll go ahead and run that. So after I've moved it, charged it up, and then it was 80 kilowatt hours. Now I moved it 300 kilometers. Now I'm down to 8 kilowatt hours left, and that gives me a range of about 33 kilometers left. And of course, if I make this a little bit larger, let's say try to do 500 kilometers, it's throwing the exception. Not enough electricity remaining, which is 80 to travel 500 kilometers. Okay, so those classes seem to work reasonably well. So the next thing I'm going to do in my program is I'm going to deal with just showing how inheritance works with the vehicle class. Okay, so I'm going to scroll down a little bit here, and you'll notice that in the program class there is a static method called fill it up. Okay, and the parameter for the method fill it up is a vehicle. Now we know that we can't create vehicle objects, so this is a little bit weird. Okay, this parameter will represent what I end up passing to it, has to be something that inherits from vehicle, either a child class or a grandchild class or somewhere along those lines. Okay, so I pass the vehicle in, I'm calling it vehicle, whether it's a car or it's a truck or an airplane or a passenger train or whatever we end up creating. And this is what it does. So what does it do? It's going to, to the debug window, it's going to write the line, refueling A, and whatever type it is. So this is actually going to show me in the debug window, in the debug output, what type of class actually got sent to this function. And then it's going to call the refuel method, and it's basically going to refuel the vehicle up to its capacity. So it's, whatever is remaining, it subtracts that from the capacity. That's how much it's going to actually recharge or refuel the vehicle. Okay, so let's uncomment out the line. It says inclusion polymorphism, subtyping, fill the object's energy to capacity. We'll uncomment that out, fill it up, test object, and we'll try running that. Okay, so we passed the test object, which was a truck. Sorry, this is before we actually passed it, so we can see we've got, in terms of energy remaining, is 6.4%, but it is a truck, you can tell, an electric truck. So when I pass the truck to the function, oh, I've got to actually output it as well, sorry. Let me do that quickly here. There was another line I needed to uncomment, so we'll just write the test object out again. So let's try that quickly one more time. So here's the truck before we send it to fill it up, and then this is the truck after we set it to fill it up. We can see that we've got 100% electricity remaining in this particular case. If I move this out of the way and I look at my output window, I can see there's a message here, refueling a vehicle classes dot truck to capacity. So that seems to have worked. Okay, so we'll close this off. Now, let's see if that works if I change the test object from a truck to a car. So I'll just uncomment. It doesn't really matter which one I uncomment. I'll just do the default one that we started with. And of course, now it's complaining about changing the cargo load, so I'll comment that one out. Go ahead and try to run this. You know what? Since it's a car, I might as well uncomment out the passenger load plus plus, since that should work. I'll go ahead and run this. So here's my car after the various different modifications that we made to it. And then after we fill it up, okay, we can see it's at 100% again. If I'm just going to close this off. Actually, I should rerun it so that we can see the debug window here. So there's the same car again. I'll just move it out of the way, and we can see it's refueling a vehicle classes.car this time to capacity, which is what we wanted. So the next thing that we'll do is we'll test out the and show an example of interface-based polymorphism. So to do this, it's going to be very similar. So I'm going to add another method, okay, similar to the fill it up method. And what this method is going to do is it's going to take an I passenger carrier as a parameter. Okay, so you don't have to watch me type it. Let me just paste it in here, or pause the video and type it in. Okay, there we are. If you need to pause the video to type this in yourself, I recommend that you do that. So just stepping through it, again, it's a static method here in the program class. It's a void method, meaning it doesn't return anything, and it's called move random people. So the idea behind this method is it's going to load a certain number of, or a random number of people into whatever passenger carrier I happen to send to it, and then it's going to move that passenger carrier a certain number of random kilometers. So in order for this to work, I need to be able to access the passenger capacity, passenger load properties, as well as the move method. Okay, so whatever I send to this has to have all those things. Well, if it's a iPassenger carrier, if it supports that interface, then it will have those things. So my parameter in this case is an kind of like a variable of iPassenger carrier. What I send to this typically would be an object of a class that supports that interface. Okay. Right now in our project, we only have the one class that supports that interface, which is car. So I'm going to be passing a car to this. If I pass a truck to it, it's not going to cut it because truck doesn't support this particular interface. Later on, when we create our own classes, you're going to create a passenger train, and we're going to try passing the passenger train to here, which will support the iPassenger carrier interface, and you'll be able to see that it still works. So internally, I've just arbitrarily set this limit. This is in kilometers. 1,000 kilometers is the most that I will move the carrier that I send to it. That might be too much, by the way. This might throw an exception. I create a new random number generator. I've called it generator. That's for generating my random numbers. I'm going to just use the debug class here to write a line to the an output window saying, you know, it's loading a car in this case, vehicle classes.car with random people. And then I actually increase the passenger load by a random amount between one extra passenger to up to the actual capacity. Okay, so I'm not going to overflow the passenger carrier, but I could, you know, potentially fill it all the way up. And then I write another debug message. This is just telling me that I'm about to move the vehicle classes.car a random distance. And then I call the using this, you know, variable of iPassenger carrier type dot move somewhere between 1 and the limit. Now, of course, you know, the car might not have that kind of a range or distance remaining, so that might throw an exception. I could have tested for that, but whatever. This is just an example. So hopefully you've got that all typed in and ready to go. Let's test out actually calling it. So you can scroll up to main, and I believe I have this, you can just uncomment it out. No, we'll have to type it in, sorry. All right, so what we're doing here is interface-based polymorphism. I'll put a couple of comments. Interface-based polymorphism, move random people some random distance. So I'm going to say my move people randomly method, and I'm going to pass it. You can see here with IntelliSense, it's expecting an iPassenger carrier variable. Okay, so I'm going to pass the test object, which I believe is a car at this point. So hopefully that will work. We'll try running that. So I'll save it and try running that, and we'll see what we get for our output. Okay, so this was our car after our little initial modification, and then this is our car after we fill it up and then move it with some random people a certain distance. So what we're seeing here is it's a different passenger load, okay, and a different range remaining. All right, so let's try running that another time. We'll get some different random numbers, I think. Okay, so initially the car is the same. Run it again. It's different passengers. I think this time it's 2. It was 3 before. Different amount of electricity remaining. Okay, so it's hard to you know, obviously truck doesn't support that interface, so we can't test it with a truck. But we'll change this test object to something else that supports it in another video. So that was a big one. In the next video, we'll start doing more hands-on stuff where we're creating our own classes, following the same sort of pattern. Thank you.